All right, I think we're ready to get started. Now, on as far as the exam is concerned, I know that a lot of times I'll hand it back and then we have questions over certain parts of it. What I normally do is I post the answers to the exam in Canvas. Now, I have not done that yet because I'm still waiting on a few students to take makeup exams. So in fairness to everyone else, I don't want to show someone a copy of what I asked everyone to do. So you understand, you're just going to have to hang tight. So what I encourage you to do is anything that I took off on that exam, just go look at it, see if you can figure it out. And if you have questions, either come to my office or next class, we can start class with questions, okay? But I want to give you time to reflect on the exam yourself rather than me just going, oh, this is how you do it, this is how you do it, this is how you do it. You try and figure it out. Sound fair? Okay, we're going to start 3.6 today. This is an introduction to what are called functions. No, we're not actually. We bounce around just a little bit here. This section was supposed to be on this exam that we just took, but we decided that we didn't want, well, I decided that I didn't want to force this into the exam, so I opted to leave it off and start here. So we're going to talk about this section, then as soon as we're done with this, we're going to jump into a different chapter. So this is just to get us thinking a certain way before we start chapter 5. So intro to functions. First, what I'll begin with is the idea of a function is something that's going to be used a lot in future math classes. Like how many of you have to take college algebra? Okay, college algebra is all about functions. How many of you are going to do 1324 as a business math instead? Business math? That's all about functions. So it's really hard to do any more math after this and not talk about functions. And this is kind of your introduction to it. A lot of you have seen it before, but we're here to kind of start at ground level again. So here's what I like to use as an analogy of a function. I'm going to try and draw this pretty good. You don't have to copy my drawing. This is a car wash, okay? Have any of you ever used a car wash before? Like the ones like at HEB that they have next to the gas pumps and you pay and you go through and you take your car in, right? Okay, I want you to look at a car wash as being a function. What we put into the car wash, right, our input for a car wash is usually a car, right? Usually a dirty car. Done with that? Anyone else need to sign in? All right, and what comes out of a car wash? Clean car, right? Output, unless it's a crappy car wash. So your output is clean car. A couple of things to kind of pay attention to here. Most car washes, right? At least every car wash I've ever been to, you put a single dirty car in, right? And out the other side comes a single clean car. You never get one car in, two cars out, right? That would be the best car wash ever, right? You put your car in, you get two of them out, and then you go sell one, then you put another one through and get two again, you go sell. I mean, obviously that doesn't happen. But what are you talking? There's a car wash that does that? Oh, but there you're putting 4 in, getting 4 out, right? You're always going to get, for each one that goes in, only one comes out. That's kind of what I'm saying here with the function. One input, one output, right? That's a property of functions, one in, one out. Another thing to consider, I'll put that underneath here, one in, one out. One in, one out. Another property of a function is that your average car wash on the corner of whatever neighborhood you live in, you can't put like an 18-wheeler through it, right? I mean, car washes do have some limitations. They have height restrictions, width restrictions. Certain trucks even can't go in there depending on how big they are. So there is sort of a restriction as to what can go into a car wash sometimes. And what we call that is the domain. The domain is basically what you can put in to the car wash, all right? We're going to make this connection with what a function is. I'm just using the car wash to kind of get us thinking with something that we can relate to. And then you have this thing that's called the range. And the range is the outputs. All the clean cars is the range of the car wash. Okay, so for a car wash, which we are going to say is a function, you have inputs and outputs. For every input, you have one output. And there's sometimes a restriction as to what you can put in. And whatever comes out of it is called the range. So my picture below this is going to be, instead of a car wash, it's going to be my function. And in mathematics, what we normally plug into functions are numbers. Number in. And usually a function, what a function does is it changes that number. Now sometimes it won't. Sometimes it'll just leave it alone. But a number goes in, like a dirty car went in, and then what we get is a new or cleaner version or different version of the number. So we get a new number out. Number out. One input, one output. That's very important. For each input, we have one output. What do you think the domain is? What's the domain? Well, it'll depend on the function, but just like the car wash, we couldn't put, an aircraft carrier through a car wash. You can't put, sometimes your function can't handle certain numbers. So the domain is what numbers you can plug in. Numbers, little number symbol, numbers you can plug in. And then the range is everything that comes out. The numbers coming out. All right. Any questions on that? I have a question. When would you ever use a function in the real world? Anybody here work hourly? Anyone here have a job and work hourly? You have how much you make an hour, right? That's a function. I'll just show you. I'm going to make it up. I don't even know what minimum wage is. I don't even care. Let's say that you make $15 an hour, right? You have a job, you make $15 per hour. Well, I can come up with a function that would tell me how much I would make if I work a certain number of hours. If I take that 15 and multiply it by x, and I let x be how many hours I work, then if I work 1 hour, how much do I make? 15 times 1 would be $15, right? If I work 2, then it would be 15 times 2 is 30. So x here, if that's how many hours I work, then 15 times x represents how much money I make, right? So you can almost look at it like this. Here's your function. Your input is the hours you work. Your output is the money you make, right? I mean, that's basically what we have here, a function that gives you how much money you'll make if you just tell me how many hours you work. Does anyone here pay their own utilities? Okay, pay their own utilities. You pay your, how much you pay CPS or whatever it is, or if you're on these data plans on your phones, everything is determined by how much you use. That's a function. You plug in your usage, it spits out your cost. So functions are all over the place. We just have to kind of pay attention and we'll see them. We're going to start today, though, with some notation, all right? How do I let you know we're talking about a function? Notation. If I write this, Wondering, I guess I'll start off kind of nice. There. That's the way we would write a function. I'm giving you a specific example. So this is a specific car wash, all right? It's no longer general. It's a specific one. It does a certain thing to a number that you plug in. Some language here. The f that you see out here, this is what we call the name of the function. So the name of this function is f. This is the f function. The x that you see here in the parentheses is our input. So remember we said we're going to plug a number in, plug something in. It's going to spit something out. The x is what gets plugged in. And then what's over here is that's the actual part that's cleaning the car. That's the part that's changing the number. This is what determines your output. Now, if you were to be reading this to someone, you know, like you read a book, you open up, start reading. If you were to open up a math book and you see that and you were trying to say it to someone, here's the way you'd say it. You would say f of x equals 3x squared minus 5. The key to what I wrote up here is this part right here. That's the way you say the left side of that equation. F of x. F of x. Okay, everyone understand the notation? Let's do some examples. I'm going to actually give you a function now. I'm going to ask you to plug something in. I want you to tell me what comes out. And let's just use that example. So example, let f of x be equal to 3x squared minus 5. Find the following. F of 3. Do y'all know what a God complex is? Have y'all ever heard of that before? A God complex? No? Yeah, it's called a God complex. A lot of doctors who like save people's lives on a regular basis get that sort of God complex. You know, heart surgeons and stuff that go in and every day they're like saving people's lives. They get kind of this, some of them get this feeling like, you know, God complex. I save people's lives every day. Before I go to lunch, I've saved 3 people's lives, you know. What did you do today? You know what I'm saying? I'm bringing this up for a random reason here. This is the one time in my life that I get to like have that God complex. I say let f of x be a function. I get to control the function. Here it is. Let this be. There's the function. Now I get to ask you questions, right? So when you see anyone in math, this isn't just me, if you see someone say let this be, it's they are defining something for you. They're saying this is the definition of f now. F is that. Tell me what f of 3 is. So what we're going to do is this is the car wash. 3 is going in, right? 3 is going to go right there for that x. That means 3 is going to go right there for that x. So what we'll do is we'll just write, I'm going to write it all out, the 3. Then I'm going to square 3, then subtract 5. Everyone see where that came from? Okay. I put it in parentheses for a reason. Do you think it's important? I'm going to square that 3, right? I'm going to square this 3 right here first, right? Square that first. What's 3 squared? 9. Then I have a 3 in front of it. What's the operation between 3 and 9? Multiplication, and then I have minus 5. 27 minus 5, 22. That all right? So if you want to look at it this way, we plugged in 3, it went through the function and came out 22. Dirty car, clean car. Number changed through the function, right? The book refers to these as ordered pairs. The book will write it like this. They say 322. They call this an ordered pair, meaning the parentheses will just always be here. It says 3 goes in, 22 comes out. And that's the way answers in the back of the book are going to appear for your homework. 3 goes in, 22 comes out. Y'all follow that? Okay, let's stick with the same function. I want us to find how would you say that? Someone read this to me. Find f of negative 7. Good. Find f of negative 7. Let's see. See if you can do it. I'll give you 3 seconds. Okay, that's good. I'll give you more than that. Got it? I think we're starting to lose some people here. Y'all there yet? Anyone want to be brave and share their answer? Positive what? 49? Any others? 142? 142? 142? Anything else? Okay, let's see here. We have 3, right? And we're replacing x with negative 7. So I put negative 7 here, and then square it, don't I? Then minus 5. So what I have to do is I have to square my negative 7 first. Negative 7 times negative 7 is 49. Positive 49, right? Did you do 14 by chance, or no? Times 49, and then minus 5. And then multiplication comes before the subtraction, right? So 3 times 49, 147. And then your minus 5, 142. Sounds good. Is everyone okay with that? Does anyone need me to clarify that? You sure? All right. I can. Just tell me what you need. Okay. Let me see here. You seem to be too good at this. Let me see if I can slow you down a little bit. What? It's a fraction. What's the big deal? So don't let the fraction freak you out. All you're doing is replacing the x with that fraction, right? We just are going to have to pay attention to some things that we haven't had to pay attention to. So I have 3 in here. Am I letting you work it out? Okay, go ahead. I'll work it on the board, and then I'll talk through it in a second. I think that's as far as I'm going to go, and then I'll talk through it. Oh, there is a ruler here. Okay, that's replacing the x right there with -3/5. I'm going to square that, which means multiplying -3/5 times itself. Then you multiply straight across. -3 times -3 is 9. 5 times 5 is 25. So you get 9/25. So this becomes 9/25. Then I have to multiply 3 times that, which I did over here. That's the same as 3/1 times 9/25. Multiply straight across, 27/25. So that's 27/25, and then I still have -5. Now I rewrote 5 as 5/1. Why? I have to subtract them, right? And to subtract or add fractions, you have to have the same denominator, don't you? And so if I'm going to do these two together, I'm going to need a 25 on the bottoms, right? How do I get a 25 on the bottom of this 5? What do I do top and bottom? Multiply top and bottom by 25. So I did that over here. I took the 5/1. I multiplied 25 on top and bottom. That gave me 125/25. Okay, that's where this 5/1 turns into this. Because that's still 5, isn't it? It's just a fancy way of writing 5 so that I can combine them together. Now I do 27 take away 125. What's 27 take away 125? -98 over 25, our common denominator. Questions? Can I clarify anything?
So on that work on the very end, is that supposed to be 125/25?
Yes, right here.
Oh, okay. So that top number is not 25/25, right?
Where, right here?
Yeah.
Yes, this is. See, I'm going to draw on this. It doesn't work up there. I'm trying to take 5, right, which is this, 5/1, and I'm trying to rewrite it with a 25 in the bottom. The only way I can ever make this a 25 on the bottom is if I do something to the bottom and the top at the same time. Because isn't 25/25 1? So this is really just a 1. So I multiply here, 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 and that's where I get the 125/25. Does that answer your question? Any other questions? So, I mean, it's obvious when I throw fractions in there, it gets a little more complicated, right? Moving on. Oh, well, the book is going to ask you for the ordered pair. Yeah, let me go back and just tell you what that would be as an ordered pair. Our answer would have been, matching the back of the book, it would have been, what did we plug in here? -3/5, so in parentheses, -3/5, and then -98/25. That's the way it would be in the back of the book right there. On an exam, I won't specify. I'll just say, you know, evaluate this function or find this. If you just give me that, I'll be happy. But just realize when you're doing your homework, when you look in the back, you're like, what the hell is that? Like, all they did was put what you plugged in here and then what you're supposed to get out right here. So your answer will always be that piece right there. Okay, going back to another example, so I get my little God complex here again. H of t equals 4 minus t squared over 3t. So since, for the moment, I was allowed to be the one in charge, right, and make up whatever I wanted, I decided to call it h instead of f. Okay, so the name of this function is h. And instead of using the variable x, I use t instead. It's my choice. And the book does the same thing. They switch things up like that. So I don't want you to be freaked out when you see an H and maybe they use a W instead of an X. Those are called dummy variables. It's just a letter that represents a number. Okay, so let's take a look at this function. Let's plug in a couple of interesting things into this. First, find f of negative 4. See what you get. So remember, all we're doing is replacing all of our t's with whatever we're plugging in, right? What should that turn out to be? Notice my parentheses here. My t is negative 4, isn't it? And so I put it in parentheses, and I'm squaring that. The negative sign in between is still going to stay there. So what's negative 4 squared? Positive 16. All over 3 times negative 4 is negative 12. The numerator, which is the top, right? 4 minus 16 is negative 12 over negative 12. This is 1. Right? So again, going to the back of the book, that would be negative 4, 1 if you looked at it as an ordered pair. So when we plug negative 4 into this, it spits out 1. What happens if you plug in 2? Oh. What is it? What over 6? 0 on top, right? The top is 4 minus 4 over 6, which is 0 over 6, which is 0. It's okay to have a 0 on the top of a fraction, right? You just can't have it on the bottom. Last one on this one. Find f of 0. So try and plug 0 in. What do you get? 4 minus 0 squared on top over 0. 4 minus 0 is 4. 4 over 0 is... Wait a minute. I forgot the 3. Well, 3 times 0, though, is what? 0. What's 4 over 0? Undefined. Undefined. That's what I was just saying. If you have a fraction, you can always have 0 on top and a number on the bottom. That's okay. No problems. The answer is 0. You can't have it the other way around. We are not allowed to divide by 0 in our number system. So undefined is the answer. So what happens when we plug in 0? Okay, this is like trying to put the 18-wheeler through the car wash. This function cannot handle 0. Does that make sense? So 0 is actually a number that would not be in the domain of this function. So like, we have a big sticker on the outside of the car wash that says, don't put an aircraft carrier, don't put a plane, don't put an 18-wheeler through this. It says all the things that can't come through, right? Only small cars. Our little sign warning everyone, here would say just don't try and plug 0 in, okay? 0 can't come into this function. It won't be able to do anything with it. All right, let me try a different example. Let's try this. Let f of x be equal to negative x to the, or let's make that a 4, x to the third minus x squared plus 2x minus 5. Find f of 3, f of negative 2, and f of w. See how you do on that. I'm going to give you a few minutes. This is 3 different things I want you to plug into that function. Everywhere you see an x, right, you're going to replace it with, first you do this one, right? Y'all understand these are 3 different problems? Okay. Do that one, figure out what the answer is. Then come and do that one, figure out what the answer is. Then do that one, figure out what the answer is. Okay? I'll let you do that so you can get some practice. I can tell by looking at you, you're kind of upset that I'm not sharing with you enough. So go ahead. The last one I haven't shown you how to do, so I'm going to finish this and see what you can do. Did anybody come in and not get their exam from me? Just a quick look at these surveys y'all did. Everyone wants me to stay with this. Unanimous. That's in both classes, so pretty interesting. We'll stick with this then. Is that right? No, 80. That's not right. Anybody get 100 for the first one? Yeah. Anybody need help with the first one? Raise your hand. This is like an exercise in signs, isn't it? On the second one, making sure you get all your signs correct. Does anyone have an answer for the second one yet? Negative 45? Yes or no? See, on the second one, you plug in your negative 2's. You have to cube the negative 2, which is negative 8. Square negative 2, which gives you positive 4. Positive 2 and negative 2 is negative 4. And then minus 5. Then we have to combine everything together here, multiply where necessary. 4 times negative 8 is negative 32. Take away 4, take away 4, take away 5. Negative 45. Is that what you had said? Negative 45? Sounds good to me. Now, what about f of w? Or does anyone have a question on this second one? Yes. Uh-huh. It is, but notice I highlighted just the yellow here. This yellow becomes positive 4, but what was still out here was this minus sign. See that? So the yellow part turns into a positive 4, but because I had subtraction, it's minus a positive 4. Does that make sense? Okay. Notice on the next one, the one in green, positive 2 and negative 2 is negative 4, but because that was a positive in front, when I add a negative number, it's really subtraction. So notice I carried the highlight out this way. That's to show you that this did become a negative. All right. So what does f of w mean? Yeah, just put w's wherever the x's are. And so it'll look like this. F of w equals, I forgot what the function was, 4w cubed minus w squared plus 2w minus 5. And that is it, okay? You can't do anything to that because you don't know what w is. Can you imagine plugging a fraction into that one? No? Wouldn't necessarily be that great, would it? It could be done, right, with enough time and patience. You could probably plug a fraction in. For your homework, page 242, 37 through 51 odd. Now keep in mind here that the book says to write your answers as ordered pairs. So if you flip to the back of the book, you're going to see the ordered pairs. It'll look a little different than what we did in class. You know what I'm saying? Like this answer was negative 45, but the book would have had -2, -45. Right. So just keep that in mind. Anything else? I'm going to end a little early in case anybody does want to talk to me about their exam. We've got another 10 minutes, so I'll hang out here. I'll shut down the video, and then if you want to look at anything off your test, hey, why'd you take off for this? Or, I don't know what I did here. Just come talk to me, okay? See everyone on Thursday. Do your homework. Have a good day.